So let us do the first problems, the Rolle's theorem. There are three conditions. First, the function should be continuous, right, on the interval. Second, f is differentiable. And the third condition, f, suppose we are given the interval from a to b, from a to b. So this is the Rolle's theorem. And the third condition would be fa is equal to fb. Then we have the conclusion that there exists a number in the intervals a and b such that f prime of c is equal to 0. This is the theorem, right? So now we observe that the polynomial in our case is the function f is 1/2 of x minus square root of x, right? So we see that f is f of x is a continuous is a polynomial of degree 1, subtract a radical function. And the radical function is continuous on its domain. Therefore, this function f is continuous in its domain. And the domain of this is for any value of x which is positive because there is a radical sign. So we see that the first things, f is continuous on 0 to infinity, right? Therefore, it is continuous on the interval from 0 to 4. That is the first condition, and it's satisfied. The second one, and we know that f is the sum of a polynomial of degree 1 and a radical function, therefore it is differentiable. On these intervals, or it is differentiable on the interval from 0 to 4, right? So the second condition is satisfied. So the third condition, we need to compute f at 0. And we see that f of 0 is 1/2 times 0 minus square root of 1/2 of 0, right? Which is simply 0, okay? Furthermore, the function value at 4 is 1/2 times 4 minus square root of 4, right? Which is 0.5 multiplied 2, it would be 2 minus square root of 4, which is 2, therefore it is 0. Hence, f of 0 is equal to f of 4. So the third condition is satisfied. Therefore, for number 2, is fx differentiable on the open interval, or does it? Yeah, it is a very good question. So differentiable, we need, it is differentiable on an open interval, yeah, from 0 to 4. Because if the differentiable, if in a closed interval, we use a yeah, this is in an open interval. Oh yeah, you're right. I see what you mean. Yes, it is open interval. Thank you, Faith. Yes, it is differentiable in an open interval. Very good. Good catch. Therefore, thank you. So it is differentiable on the open interval from 0 to 4. It's satisfying 3 conditions of the Rolle's theorem. Therefore, we have the conclusion. Therefore, there exists a number in the interval from 0 to 4 such that f prime at C, a number, let us call it C, in the interval such that f prime of C vanish. Okay? But we see that f prime of C f prime of x in general, it will be the derivative of 1/2 x minus square root of x here, derivative. It will be 1/2 x prime, right? Minus square root of x derivative. Right, and x prime give us 1. It means the first term becomes 1/2. And the second one, derivative of square root of x will be 1/2 square root of x. So we have this, very good. In the open interval 0 to 4, it means that the number 0 is excluded. So we are good with the f prime here. So what we need to do is to solve the equation f prime of x is equal to 0. And this guy, f prime of x here, we can write it as, if we multiply this guy with square root of x and divide it by square root of x, right? It will be the same things. But now they have the same denominator. Therefore, we can write it as square root of x minus 1 divided by 2 square root of x. And it is clear that the solution of the f prime here will be from this. If we solve this, it is equivalent to solving square root of x is equal to 1, is equal to 0, or square root of x is equal to 1. Therefore, x is 1, right? Therefore, the number C, which is 1 in this case, satisfying the conclusion of the Rolle's theorem. And f prime of 1 is equal to 0. And there is only one solution in this case, right? So therefore, C is equal to 1, satisfy the conclusion of the Rolle's theorem. That's it.